Very good morning to all. So this is a series of lecture of HMT 2, which is the concept of convection under the subject of heat and mass transfer for the sixth semester mechanical engineering. Let we see the design thinking based explanation of convection. So we know that we have to recall. So we know already we had seen in the previous lecture what is conduction. So transfer of heat, metal to metal, which is said to be the conduction. And what are the modes? So how the heat transfer takes, it is divided into three modes. One is conduction, another is convection, another is radiation. So this is the second mode of heat transfer, convection. So what is the medium? A medium is nothing but which carries, particle which is carrying the heat from one point to another point, which is said to be the medium. And the mechanism, how it is taking place, how the heat transfer taking place, that explanation is said to be the mechanism concept. So now let me get into the topics for discussion. So design thinking stages in terms of convection, convection heat transfer types, mechanism of convection, heat transfer coefficient, law of governing equation, and assessment. These are all the concepts we are going to see under the concept of convection. So now we see the design thinking. First, we have to empathize the thermal concepts which are related to the design thinking. So again, I'm repeating that we SNS is the first Indian institution to implement the design thinking concept in the curriculum and syllabi and students activity and outcome based activity also. So empathize where we decide where to implement this concept, how to implement all the empathy head to toe problem from the end user we collect and we define and we make ideation from brainstorming and create a prototype, then we are testing it. So this is the concept of design thinking in the concept of this convection. So types of convection. So already we had seen conduction, now we are seeing convection. There are three types of convection. Convection is the movement of fluid that transfer heat. It is classified into natural, forced and mixed type of convection. Natural convection, in this diagram itself, it is shown that if it is happening naturally without any external aid, without any external force, the warm air rising from the candle due to buoyancy effect. So this is natural convection. Otherwise, it is called as free convection. Forced convection, when we use the fan or blower, which is taking the heat from one point to another point with the external aid. With help of external, if it happens, that is said to be convection. So mixed convection, it is having both natural as well forced convection. Here fan is there, forced convection. Naturally, it is rising due to buoyancy. It is said to be natural. So mixture of natural and forced convection. Heat transfer is said to be the natural and mixed flow convection. And mechanism of convection. So we know that heat always rises up due to buoyancy. Cold always falls down because of density. So when the temperature of the fluid is higher than the surface temperature, the convection taking place. So it is keep on repeating. When the fluid carries the heat from solid or from the fluid, that is said to be the convection. If the transfer of heat between surface and the fluid motion, that is what given here, it's an ideate process. During the conversion, warmer, less dense fluid rises. When cooler, dense fluid sinks. That's what I explained already. So this is belongs to the material property and the fluid heat transfer coefficient that we'll see in the upcoming topic. So heat transfer coefficient, which is indicated by the notation S, that is H. This H is indicated by the unit watts per meter squared Kelvin. In case of conduction, the uh, W, the K is the constant, that is heat transfer conduction equation, thermal conductivity equation, that is watts per meter Kelvin. Here H is watts per meter squared Kelvin. The heat transfer coefficient, which represents ability of fluid to transfer heat between solid surface and surrounding fluid during convection. It depends on fluid properties, fluid flow, surface condition, nature of the convection. So coming to the high heat transfer coefficient and low heat transfer coefficient comparison. So water having high heat transfer coefficient 500 to 10,000 watts per meter squared Kelvin, whereas oil having the very less heat transfer coefficient 5 to 50 watts per meter squared Kelvin. So other steam condensation of surface, air, natural convection, insulated gap, all the values are given there. Then we go for the governing law. So already we had seen a governing law for the conduction. It was a Fourier law of heat conduction. Here for the convection case, it is Newton's law of cooling. Convection is cooling. It is given by Newton's law of cooling. The Newton's law of cooling states that the rate of heat transfer by convection between a solid surface and surrounding fluid is directly proportional to the surface area and temperature difference between the surface and fluid. So the equation is indicating Q equal to He delta T. Delta T is nothing but surface temperature to the ambient temperature. So here the H is watts per meter squared Kelvin, Q is in the watts unit, area surface area meter squared, surface temperature Kelvin or centigrade, temperature of surrounding which is Kelvin or centigrade. If we recall the concept, so convection heat transfer is used in cooling of electronic devices and engines by circulating air or liquid to remove the excess heat. It is used in the blower and furnaces also, convection. And coming to the summary, these are the concepts we have seen under the case of convection, DT stages, convection type, mechanism, heat transfer, governing law assessment we are going to see now. So, curiosity challenges. So, think about which mode of heat transfer makes higher heat transfer, whether conduction or convection. This you think per share, you will get a good conclusion. If it is a forced forced convection is a good idea for heat transfer. If it is not a forced convection, then conduction is the best one. So coming to the assessment, which mode of heat transfer involves fluid motion? Fluid motion. So conduction, convection, radiation, and none of the above. So they said about the fluid motion. Fluid motion is convection. The law governing convective heat transfer is said to be Fourier law, Stephen Boltzmann, Newton's law, Fick's law. So just before we seen that Newton's law of cooling. Let we see the answer B and C. That is convection and Newton's law of cooling. So these are my references, and thank you very much for your listening. Thank you once again. Thank you.